afternoon, Miss and teacher. We're going to talk about the comparison of approach, mean variance and mean semi-variance to choose an portfolio of an agricultural portfolio. Objective. Compare the method proposed by Markovich and the method proposed by Estrada to choose an agricultural portfolio. Markovich. The method developed by this author is based on rational behavior of the decision maker regarding that he prefers return and reject risk. When variance is used to obtain risk, there is a latent problem that both variation are above the mean and variation below the mean are included in the measurement, which only negative variation are effectively lost to the producer. This problem has led to the alternative measure of risk, known as semi-variance, which considers the risk only from variation that are below to the mean or negative. Problem of semi-variance. The problems are difficulty in its calculation and at the same time lack of measure for than two assets comprising a portfolio. Estrada proposed a solution to the above problem, generating an easily and accurately symmetric X-general matrix of semi-covariance that tend to produce better portfolios than those based on variance. Important to assess the risk of investment in certain inherent uncertainty to activity, climate condition, incidence of pest, disease, and other due to the uncertainty into market. Agricultural portfolio consists of tomato, potato, beans, maize, and sorghum. Statistical data. The statistical data come from a statistical yearbook of Mexico, issued by the Instituto Nacional de Estadística y Geográfica. From this yearbook, we obtain the annual return per hectare harvest in Mexico.
Well, the principal reason about this paper is to compare two models, the Markovich model and the Estrada model. We have the first one is the mean variance model, the objective function. We have the variance of the portfolio. We have the double sum of a dummy variable and the covariance between the curves of E and G. The restriction function are the return expected of the portfolio equals to the sum for the proportion of the portfolio times the return of the portfolio of the curves E. Well, the sum of the proportion of the portfolio is equal to 1. Well, the mean semi-variance model, we have first the semi-covariance that is like an average of the two terms in a function. We have the first function is a minimum of the return of the curves E minus a objective return of the portfolio. And the second one, we have the return of the yield in the portfolio. the restriction of the model, we have first the return expected of the portfolio is equal to the proportion times the return expected for the curves. The second one, we have the semi-variance of the portfolio, and is equal to the double sum of the semi-covariance. We have it is like a sum of a matrix of the crops. We have the variance of the crops, of the portfolio. Is that is the return of the portfolio.
The results are present via frequency histogram to see if the solution differ. Figures 1 and 2 show the 100 optimal share for maize under each solution. It's note that the under the result present, both methods solution match the optimum share under each approach is 0.45. For further support of the result, the test was performed for the optimum share of each crop under the null of equal share for each method, an alternative that the shares differ according to the method used. We can see the 2t value is it's greater than 10%. From these results, it's observed that there is no statistical difference in solving a method and another, or the assertion of Strada that this method generates a more efficient portfolio isn't proven in this study. And finally, line conclusion. By having two alternative ways to solve the same problem, the dilemma of assessing what is best arises. However, it was found the no result is statistically differing from the solution proposed by Markowitz.